Well, hello my CNC brother or sister. I'm Garrett with IDC Woodcraft, and I want to give you a big fat welcome to this video where I am going to dive deep into a question that I get all the time in email and on the YouTube channel, which comes from brand new CNC router owners. And that question is, how am I supposed to know when I need to change my bit on my CNC router while I'm carving my project? So let's say you've designed this very cool Jeep plaque where it says, "Don't follow me, you won't make it," and it's got detail in the Jeep and some cutout here. So the scenario is, on this, you have a V-bit that's carving out the lettering, the stars, the Jeep details, and then you have to change your V-bit to a down-cutting or up-cutting bit to cut out the profiles. How are you supposed to know when that bit change needs to take place? Does your software tell you? Does the CNC router tell you? Well, this is exactly what we're going to dive into in this video. There are three ways that this actually can work, and that depends on your CNC router and the control software that's running your CNC router and something called a post processor. But I'm going to cover the most common way that most CNCers have to deal with this. It really goes along with the benchtop CNC routers. And so we're going to dive into this by going through a project I just designed for my daughter, this LED acrylic project that has a lot of meaning. So I'm going to just kind of run through it real quick. I won't actually do the design work, but I'll show you about the setup for the tool change and why this tool change takes place in the way that it does and the way it's going to work for you. So on this project we will have one bit change. We're going to start off with a bit called an O-flute bit. Now this is designed to carve the acrylic material, and then we're going to switch over to the Widget Works diamond engraving bit to get a lot of fine detail into this project. You're actually going to love this bit, and by the time you're done, you're going to know a whole lot more about this than most CNCers know, because I'm going to give you it at the technical level so you understand the back end of it, why it works this way. This works for anybody who has a benchtop CNC router, and it doesn't matter what design software you have. I'll explain all this as we get into it. You're going to be so smart by the time you're done with this. Let's go. Before we get into the software and talk about the back end, I want to talk about the front end and just clear up who this video is for. If you have purchased a benchtop CNC router like the Longmill, which is the one that I absolutely endorse, and it has a trim router mounted to it. A trim router is like the Makita or a DeWalt. It has a power switch on it somewhere, a little speed dial on it. It plugs in independently. You can take it off and run it. It's a completely independent machine to your CNC machine. CNC stands for computer numeric control, and it is basically a machine that just moves around in space in an X, Y, and Z fashion. And then when you attach the router to it, that's what makes it a CNC router. If you have one that has this type of setup, this video is for you. If you have one that has a tool changing probe set up on the side and it has that feature within it, within your router where it can use that probe to set itself, then that's kind of the next level, but it still applies here to you. The third one is when you have something called an automatic tool changer. Now, automatic tool changer is when all your router bits are already set up in holders and they're stationed along here or back there or in something called a magazine where they're all mounted in magazine indexes, and the router itself goes back and gets the next tool and goes right into its carving. That's an advanced machine that's got a lot more to the brains of it, very expensive. Most people get these benchtop machines like the Longmill, so that's what we're going to cover in this video. So let's get into the software. I'm going to talk briefly about this acrylic project and then how it's set up with a bit change, and then we're going to get into the bit change itself, and then we'll actually carve it out, and you're going to learn a bunch of details along the way, lots of tips and tricks as we go along as it relates to CNC routing. Okay, we are in the design software where we're creating toolpaths, and we are going to define the points at which we are going to change our router bits. So first two things I want to tell you. It doesn't matter what software you have, for your CNC router, if it has this area where you can do your toolpaths, where you're telling it what bits to do what, you have the ability to write the code, and this is where the tool changing aspect comes into play. And all the design software has this feature in one way, shape, or form. The second thing I want to tell you is I am in the Vectric Vcarve Pro version 11 software. And if you are a Vectric user, it does not matter if you have Cut 2D, Vcarve, or Aspire. This works the same way in all of them. So here is our project, and this is how it's laid out on the machine. The first two things that you see is, one is it is sideways, and number two, the text is backwards. The reason it's backward is because I'm carving on the back side of the project, and the reason I do that is because it just looks better from the front if the engraving on your acrylic is done on the back. The diamond engraving bit is doing all the design work on the project. Now you can do it with what they call flute bits, which I'll be demonstrating in a minute, or you can do it with an engraving bit. And I love the engraving bit because you can get really super fine detail if you want a really ultra detailed project. And then I have the lower corner here, and you see that's cut away. And I've cut that away so it'll sit in the LED base like this. Everything I'm talking to you about, there will be links for everything down in the description below, and if there's other things I think of along the way, then I will let you know that I will have a link down below. So the first thing I'm doing is doing the work with the 1/8 flute, where I'm going to cut this green area, and then I'm going to cut out the corner, or cut it away. And then the second thing we'll do is do the engraving. Why am I doing the cutting first and the engraving second is because I will leave the protective plastic on the acrylic while it's doing the cutting, because as little pieces of acrylic go flying around, it could potentially scratch a little bit on the acrylic, and I don't want to do that. So the engraving tool does not spin. It's called a drag bit, so you don't even turn the router on, and so therefore it's not throwing a lot of debris. So here's what it's doing. I'm going to reset this preview, and I'm going to reorient the project, and I'm going to show you the first tool. I have 3 toolpaths, and the first 2 are with the 1/8 flute bit that's actually going to be cutting the project, and the last one is the engraving bit doing the design work. So I'm going to click the little white box next to the first toolpath where it says base fit. What that's doing is that is actually cutting a pocket in the project. And that pocket is actually thinning out the project material because the LED base has a slot in it that's 3/16 wide. The acrylic sheet that I have is 1/4 inch wide, so I have to make it a little bit thinner so it'll actually slip into the base. If you decide to get acrylic to do this, I suggest that if you're going to get that base, you also get 3/16 acrylic. It needs to be cast acrylic. Plexiglass does not work, or general acrylic doesn't work. Cast acrylic is interesting because it's very stiff, rigid, and if you drop it, it'll break like glass. But it's much easier to carve. So that's the first cut, is to make it thinner so it'll slip into the base. The second one cuts the corner off, and you notice I got kind of an interesting shape on that corner. I'll explain that to you in just a minute because it was a brilliant little test that worked great. And then third, with the engraving bit, it actually carves everything out. Before I go on, I want to show you the project itself and what it really is and what it means. So I'm going to just change a couple of my settings here, and we're going to flip over to 2D. And so this is the way I've designed it on the project. I've rearranged it so that you can see what it actually says. It says, "I love you, Mommy, and I'm always with you." And it has angel's wings and a heart and an M in the middle. And this is for my daughter, who 4 years ago this month, this would be in January 2022,
gave birth to Maddox, my third grandson. And a little while later, Maddox died in her arms. And so this time of year is pretty tough for her. And so she likes things like this to make her feel a little bit closer. In a way, it's sad for her, but in a way, she likes it. So that's why I'm making this. Let's get back to the other aspect of this project. We are going to have this project looking like that when it's done, except it's going to be really cool with the LED. So this is where it becomes really important for you to know and understand this bit changing process.
All right, so now I've given you a lot of precursor as to what we're going to be doing here for this bit changing thing. It's just important to understand all the upfront stuff in order to understand why we do the bit changes the way we do it and how it's going to be processed through the entire system when you get to the bit change. So we're going to get back into the design software and we're going to start talking about saving toolpaths and into the bit change aspect of this. So you're getting a lot of information. As a matter of fact, give me a thumbs up if you feel like I'm giving you some extra tips in this video. All right, let's get back into this.
In the Vectric software, we are going to go into saving our toolpath. Now, in your software, whatever you have, if it's not Vectric, you save your toolpath in one way, shape, or form. And when you go into Save Toolpath, you may have a selection in there of the machine that you have. All routers have certain codes that they have to know what to do. And it really depends on the sophistication of the machine that you have. But that code that is being put into the router is dictated by something called the post processor. And the post processor is basically a rule book that tells Vectric or your software how it can write the G code and how it can't write the G code.
Now I want to explain to you what G code is so you understand this. G code is the language that our Longmill here or your CNC router uses to know where to move to and how to move to that position and all the different moves that it makes. So G code is the language that your CNC router speaks. It's not something you have to know, but you just need to know that it is something that's in a file that's going to be dictating how you're going to be handling your router bits when you're doing your router bit changes. So that's what G code is all about. Let's get back into this.
So when we're talking about the benchtop CNC routers where you have a trim router mounted to it, there are certain conditions that have to take place to enable you to stop the router and be able to change that bit. And so that's what the post processor is set up to do. Now if you look here, I have a Longmill CNC router and currently I'm set up with a Bob CNC inch post processor. Sometimes I use the Gerbil. I have a Longmill. Longmill actually has finally written one for their machine, so I'll be importing that. And the Vectric software in the next version or upgrade will probably have the Longmill post processor in it. So anyway, but this is the dictator of how that code is written and how you change your bit. So let's explain this a little bit so that you understand what happens here. Your CNC router has a brain. It's got a control box that's attached to the machine itself. That's the electronics, that's integrating with the machine. It's built for your CNC router. And it can interpret some of those codes and other codes it can't or is not designed into the firmware on the board that tells it that these are codes we will use or not use. So with our machines, there are two scenarios that will happen. Is the software, by virtue of the post processor, will write separate G-code programs for each router bit, or it will write a code and interrupt the code with a stop command. That would be a code that says M0. And that is what they call a temporary stop. It'll pause the program, and that's where you can change your router bit. And usually when you have a post processor that inserts that code, there will be text underneath there that you'll be able to read on your display screen that will have text that will say, okay, we're using this router bit now, insert that bit. That's one way. The other way is it has the separate G-code files. Your CNC router will probably take the separate G-code files, especially if it has a trim router attached to it.
So let's just rehash this little bit again, just so you've got this clear. There's one of two ways your CNC router is going to tell you that you have to change your bit. Number one is the most common and the one that you're probably going to deal with, especially if you have a Longmill CNC router or a Shapeoko, Bob CNC, Millwright. All of these will write separate G-code programs. You have to run the program out all the way and literally load a separate program. Some other machines have a little touch plate next to it and has a little automatic cycle inside of it that requires another G-code, and that's where you'll have the MO command. It also depends on the control software that you're using, the software that is actually driving your CNC router. I use Gsender, and I will be showing you that in a minute, and the one that I totally recommend you get if you have any one of those machines that I'm talking about. So before we get back into this, I just want to say, can you please, if you feel like I'm helping you out, give me a thumbs up and maybe a comment down below of whatever you picked up from this video. And I have one other request for you. If you've been on this channel long enough, you know that I teach about business, and I also say if you really want your business to grow, you have to have a mentor, someone who is where you want to be. Because they know how to get there and they can guide you there. Well, I have a mentor, and I want to grow my business like you want to grow your CNC business. And so in our mentoring, by the way, I pay him a ton of money. You'd be surprised, because it goes into a couple $1,000s a month. Yes, that's a lot of money, but it's worth paying for that skill to get to where he's at, because he's a 9-figure earner. Anyway, the thing that we were talking about when I'm talking about scaling my business, and he said, Garrett, you have to get a pulse on your audience, the people, you that's watching the videos that I create. He says you need to know what you're doing good, what you're doing above and beyond, and also where you need to improve. You really just need to get that one-on-one feel kind of thing. So I said, okay, I'll just build a little survey where you can answer that. So if you would take a moment, down in the description is a link that says take the survey or tell me about me, how I'm doing. It's like 5 questions. If you could take a minute to fill that out, to really give me some feedback so I know what I'm doing good, what I'm doing exceptionally good, and what I need to improve on, that will help me out immensely to create an even better experience for you, get you on the CNC road better, and on and on and on. I think you get it. So if you'd take a second to fill out that survey, I'll remind you again at the end of the video. I would really, really appreciate that. All right, thumbs up, comment, survey. Let's get back into this.
So what we're going to do is we are going to select all the toolpaths together. So that means I'm selecting 2 router bits, the 1/8" O flute and the Widget Works engraving bit. And I select them all by clicking this little checkbox next to Toolpath. And when I do that, we are ready to go. Now, up here is where we're going to tell Vectric how we want that G-code written. And Vectric is going to use that determination to decide whether it can or cannot write that G-code based on the post processor that we are using. Kind of hard to explain, but think of the post processor as a gate with a set of rules that if you pass through the gate, you have to take those rules with you. So I'm going to show you what I mean. In Vectric, we're going to ignore this top button. And what we're going to do is select the second one where it says visible toolpaths to one file. What that's saying is it's going to write a G-code file with all the toolpaths that are visible. Now what visible is when whatever is checked down here, and you can see the blue lines over here, that's considered visible. So we've got all of them checked. So I'm going to click this radio button right here. and you're going to notice right away I get an error. And what that error says is the visible toolpath used different tools, and the selected post processor does not support tool changing. What that is saying is the post processor is saying you cannot change your bit in one G-code file, or in other words, we cannot run one bit, have a change, and run the other bit in one file. We have to have separate files. And the Bob's CNC G-code post processor is saying that's the rule, and Vectric is coming back and saying I'm not meeting that rule, therefore I have an error. If you use the Gerbil, many of your post processors are like that. This is why we have post processors, because every CNC router has some little difference in it that needs its own post processor. So that's why we do that. So this is not working with this button of all the toolpaths that are visible to one file. So if I look at the next one, I say visible toolpaths to separate or multiple files, and I check that, and suddenly everything is good to go. I have no error, and it has all three toolpaths listed here. That means that what Vectric is saying with no red lights here is I can write that G-code. So now we can actually save the toolpath. And what that means by toolpath is going to write multiple G-codes files. And it's going to write one for every bit that I have here. There's a little bit more to that element, which I have another video for, that explains this whole thing down here and this whole toolpath routine, which you'll want to get into. In fact, you want to download the PDF I've created that has all the videos that I have. I created that to help you stop having to search for YouTube videos to answer your questions. All the videos I've created are put in that PDF, and they're all put in order from the absolute beginner level all the way up, and it's sorted. The link to download that is down below in the description. Okay, so we are going to hit the Save Toolpath button. So I hit that, and nothing happens. Oh, there it is. Okay, so I am going to give this a name. I'm going to call it Angel, and say Save. And now Vectric has written the G-code files based on this post processor here, and for the toolpaths that I have checked that are visible based on the setting that I have up top here. So I go into that directory, and here we have two separate G-code files. We have the one for the 1/8 O flute. Vectric has merged those two toolpaths together. If you remember, I've got the two 1/8 O flute toolpaths here. Right here, I told it to group where possible. So it can group the two separate toolpaths using the same bit into the same G-code file. And so that's what it has done here. And I know this by looking at it saying Angel 1 and 2. That way I know it's got toolpath number 1 and 2. And I've named the file with the bit name in it, so I know this is using an O flute bit. When it comes to naming your files and making sure this information imports when you save this file and it imports into the name, is when you name your toolpath, make sure every toolpath is very clear in what it's doing and what bit you're using. So that's what this is. So now I can run the first two toolpaths, which are going to do this work on the project, and then when it's done running that G-code, I have to load in the second G-code, and I will know that it's with the Widget Works bits. Then I change the bit. So this is how I know. This file will run out, and then when it's done, I change the bit to the next file. So what we're going to do is go over to the Gsender software, and we're going to import it. So now we're in Gsender. Now I want to explain to you what Gsender is. When it comes to CNC routers, there's several different levels to keep in mind. One is the design software that you're working with. and the software that's going to write the G code. And that's why I endorse Vectric, because they had the design and the G code writing feature tied together in their software. And then you have this, which is called control software. And what this does is it actually runs your CNC router. It is the software that's transferring information to the router. It's where you're setting things, you're setting your bit, you're telling it where to start your cut at. There's many different things that's available in this. There are lots of different control softwares out there, and they're free, just like Gsender is. I am a huge Gsender supporter for a multitude of reasons, and I'm going to explain that here. Number one, Gsender is the most recent software. It is actively currently taken care of by the writers of the software. Most of the other control software that is out there is not being worked on anymore, or it's working on older Windows platforms, so it's not up to date. It's getting more and more bugs as things go along. This one is literally written by Longmill, which means that it's optimized for the Longmill CNC router. It will work with any other CNC router that is what they call Arduino based. That's basically the circuit board that your router is working from, and what they call GRBL, which is the firmware or the hard software on the board that dictates a lot of things. So if you have an Arduino router and a Gerbil platform, then this works for you. And I can tell you, virtually every CNC router's benchtop is Gerbil. This is why I endorse this, and why I endorse the Longmill CNC router, because the control software is built with the Longmill in mind. So you actually, the only company outside of a couple others that actually has their own control software that they have optimized for their machine, which is great. So you've got support on the software. That's the other thing. You normally don't have the support with the software, or it's separate. So lots of reasons to say, okay, the Longmill is good. It's got the software here. I endorse them both, and there we are. So what we're going to do is we are going to import that file, the first file, into the software. So I'm just going to click the load file button. And by the way, I have other videos that talk about all this and walk you through this whole process, like projects, step by step, all the way through.
In fact, one of the videos that I created is specifically for the brand new beginner that walks them through how to make this house number sign. Literally step by step from the very beginning of the design concept, and how to get these numbers in there and arrays, numbering, lettering, borders, and what have you. How to get it over to your control software like the Gsender, and then we take it out to our Longmill CNC router and run it out. So I show you how to set it up, everything, tools and everything. So that video is on that PDF. You just want to download it. I got several easy projects that'll walk through like that on that PDF. So download that PDF. The link is down below to get that. I'll put a link specifically for this video as well down below in the description too. Let's keep going.
So we're loading the first one, which is the 1/8 flute. So I'm going to click that, and it imports. And so now you can see it's got that little square area, and it's also got the little area where it's cutting out the project itself. So now it's going over to the router, getting the router set up with the 1/8 flute bit, and then we move on to the next part of the project. So now I'm going to set up the router with the 1/8 flute bit. The first bit we're going to use is the 1/8 flute bit. So let's just take a close look at this bit so you can understand how this bit works. One of the things it has is a very fast run up of the spiral right here. And what that's designed to do is to eject that plastic out really fast so that it doesn't stick to the project. The other thing we're going to be using is a reducing collet, because this is a 1/4 inch collet and I'm not using the 1/8 inch collet right now, so I'll just use a 1/4 inch to an 1/8 inch reducer. It's just a little easier
This is something that's available on the IDC Woodcraft store if you want to get one. So we're just going to put it in there, and I'm going to put it up pretty high, and I'm going to put the bit up pretty high in the collet of the machine, and then we'll tighten it down. Now once this is set up on our X, Y, and Z 0, we can leave the X, Y alone for the bit change, but the Z 0 will have to change because we'll be changing the bit. So let's set the X, Y 0 first. So now I have a little bit of room for the touch plate, about 1/4 of an inch, and it is resting right on the corner of the acrylic that I have set up here. And we're only setting the X, Y, we're not setting the Z. We'll set that differently because the Z is set off the surface of the spoil board. So that is in there, we got that connected, and we're going to go into Gsender to set up the X, Y.
In Gsender, in the lower right area, down here, we have several tabs we can choose from. We have Coolant, Console, Macros, and Probe. We are working with the probe, so that's the one we want to be on, which is what we're on right now. So I want to point out this little picture here. It's a end mill and a touch plate. And it's got a little circle on it, and the end mill is over the circle. So that is your reference as to how you want to be preset before you start this cycle. The other thing is you see these 5 buttons right here where it says axes. So depending on which one you select is what you are going to be setting your 0 reference from. So you can do Z, X, Y, Z, just X and Y, or just X or Y alone. Since we are not doing Z, we're going to do it at a second operation because we're setting off the spoil board. We just want to go with X and Y. So we select that. And then this little window down here, it's lit up, and we want to put in the diameter of our bit. So we're going to type in 0.125. And go with that. Now you notice it defaulted right to inches. If you want to work in millimeters, then you'll have to go into the firmware setting up at the top and change your defaults to metrics. Now we are set up, so what we need to do now is just press the probe button, and we select that, and this window pops up. Now you see 2 things. One, we have a red light, and we also have a grayed out button right here that we can't press, and it says no touch right here. So what we have to do first is touch the plate to the bit, and that'll ensure that we can create a contact, because if you can't create the contact and you start the cycle, then you can potentially break your bit or damage your plate. So I am just going to lift the plate up and touch the bit, and the light turned green, and the text underneath the light says touch completed. And the blue button is now highlighted. You see we went back to red. That's just however they set up the program. But we have confirmed that we have the cycle now. So we are going to start this by clicking this button. Here we go.
Uh-oh.
Now that we're set up on X and Y, now we just switch over to the Z, and you'll notice this grayed out because the diameter of the tool is irrelevant when you're doing a straight down touch. So we're going to probe again, and we get the same light. We're going to touch off on the plate. We're good to go, and we're going to press the button.
Okay, so we are set up with our X, Y, and Z, but there's one thing we need to check before you actually get started, especially when you're using clamps, and that is you want to make sure that the tool path that your bit is going to be taking will not run into your clamps. Something we don't always think about. So we're going to jump back into the Vectric software and just take a quick look at that, and then we'll verify that on this project we got set up, that our clamps are in the right position to keep from breaking our bits. Let's get back into Vectric.
One of the things that we don't always think about when we're making our projects and putting them down on our machine and clamping it down is the position of our clamps relative to the tool movements. So this is something you always want to get in the habit of being aware of. So as we're looking at the project here, this is where the tool 0 position is, lower left corner or toward me at the left. And then all the red and blue is where the bit is going to be traveling. So obviously we don't want anything inside, but we have a big open space over here. We've got a corner or an edge along here that we could actually clamp on, a space right in here, and then we got an edge along the top and along the side. So where I'm going to clamp on this is clearly up on this corner, and we have some hangout here just from the distance of the clamp. So I'm going to either clamp right here or right here, and I think I'm just going to clamp it right here. And one of the things with clamps, I always like to leave the minimum amount of clamp edge on the material, just to keep the clamp out of the way. So that's how I'm going to set this up.
And you can see that that's exactly how I have it set up with the acrylic. Right there, on that corner, that corner, that corner, I'll be clear all the way through. The only concern would be right here, and all I have to do is go in the software and measure that space to make sure that the router will never get close to there. Now I just can't take into account the diameter of the bit, but also the nut that's holding the bit, which is about 1 inch in diameter, and because the bit is only in the machine that far, it could potentially hit that clamp. So we just want to be aware of all these kinds of things. Clamp position is very important. I have a video on clamps. You can see the description down below to see that video. So we're going to hit the start button now and run out the first corner right here, and then we'll do that bit change.
All we have to do now is start the cycle, keep our eyes on it, and cut away. And we're going to hit the start job button right here, and that'll send the router going after we turn the router on. And here we go with the acrylic project. We are working at the bottom of the project, and the first thing is to cut out the area so the project will sit into the LED base, which is 3/16 of an inch thick. So that's the material you want to get instead of 1/4 inch. Now you see there's a little fuzz hanging off the side there. That's because of the protective plastic on the acrylic. This is what your chip should look like, little pieces of rice coming off of it. And if that's what you're getting, then you are in good shape with your feeds and speeds. And finally, we're going into the cutout of the base. This is the standard feed rate that we would be going at with acrylic. So you can see you do a lot of work on it really fast as opposed to wood. And that's it with the 1/8.
Now we're going to set up the Widget Works engraving tool, and I have on here currently the 120-degree engraving bit. You can get the 90-degree engraving bit as well if you want to engrave steel or other harder materials, but for this one we're going to use the 120-degree bit. Now you notice this bit is actually quite long. It's about 3.5 inches from here to here, so it'll be sitting up quite high. One thing with this engraving bit, do not turn on the router. This is considered a drag bit. So let's get that changed out.
And so we change this thing out. You see the bit looks fine, the O-flute bit. These things will last a very long time. One of the things you want to get in the habit of is cleaning out your nut and collet every time you change a bit, because debris does get caught up in there and it can throw off your trueness of your bit. Now with the Widget Works, you want to make sure it is inserted all the way into the router when you tighten it up.
Now with the drag bit, you can't use this. You cannot use it because there's no conductivity. You won't have a complete circuit because of the tip is a diamond. It's non-conductive. So we have to use the paper touch method. So we're going to touch down right here. So we want all the dust out of the way, and we're going to move the machine over to that area. And we can see by the shadow right here that we are starting to get quite close. We still have a little bit more to go, but it's pretty darn close. So we're going to take one more tab down. The good thing about this bit is if we actually touch and we don't want to, it's spring loaded. Okay, so it hasn't touched. Now I have to go into Gsender.
This time, we're not going to use the probe method. We're simply going to tap the Z down until we can't move the paper. So we're going to be wobbling the paper back and forth as we're pecking the Z down. Now, one of the things with pecking the Z down until it touches is you want to check your settings over here. You got the 3 buttons: rapid, normal, and precise. Basically, each one is, for every time you press it, it's shortening the distance that it's going to travel. For example, on the rapid, when I click that, the Z travel will be 1/2 of an inch every time I click this button right here. Under normal, it'll go 0.04 of an inch, and under precise, it'll go 0.004 of an inch, and that's the one that we're going to be using. So here we go.
Okay, so now we're tapping it. I have a video that explains how to use the paper touch method, and if you don't have a probe, how you can find the exact X, Y, Z corner of your project. So the paper is stuck. This is where we're actually going to set it. I'm actually going to nudge it down just one click more. Now every click is 0.004 inches. And then we're going to set our Z.
On the CNC router, we set the engraving bit to its 0 point manually. So that's what we're going to have to do here. We cannot use the probe feature. We're simply going to tell it where our 0 is. So if you look up in the upper right area, you have an X, a Y, and a Z. Our Z at this point is at the 0 position that we want. But you can see this number right here does not say 0, so we need to set it to 0. And the simple way you do that is just come over to the Z button and click it once, and you see the numbers have now gone down to 0. And now all we have to do is just raise the bit up about an inch or two. So we're going to do that right now. I want to come back to the Vectric software, to the design of the project for just a moment to share with you a little tip that you probably didn't know, and you will now know. An interesting little tip. Okay, so you remember I was talking about the post processor is like a gate with a set of rules, and those rules dictate what has to go into the G code of the G code and what cannot go into the G code. So it's just a set of rules. So right now I have set my diamond engraving bit somewhere over here. I've already cut this corner off, and I brought the bit somewhere in this space over here to set my Z. And I've set it, now I've raised it up. But if you noticed, I didn't try to position the bit back over this 0 start point because I don't need to. What the machine is going to do, because the post processor tells Vectric it has to insert this code, is it's going to first raise your bit up to a Z safe height. That's a position that you have set in your software for the bit to raise up to before it starts to move, make its moves. So it's going to raise up from this position to a Z safe height, and then it's going to first move over to this 0, 0 XY point. Doesn't matter where you've set your XY0, whether it's this corner, in the center, up here, no matter where your router is sitting, when you start that program, it will always go to that 0, 0, XY 00 position first after it's gone to its C safe height. And then it'll go and do all its project work, and then it's going to come back to that 00 position and end the program. So I'm just leaving the bit over here. When I start the program, it'll move over here first and then go do its carving and then come back. And all G-code programs are written like this, no matter what your machine. It's standard in post-processor rule books.
But there is one more thing I want to do, and this is the whole reason why I have run this the way I did. Because I'm going to take this film off now. I'm going to vacuum everything up. I'm going to take the film off, and then I'm going to engrave everything. The film I left on here just to protect it from all this chip in case it was flying and in case it can actually cause scratches on the plexiglass itself. Plexiglass, the cast acrylic. So we're going to pull that up after we get it cleaned up. Well, we're coming to the tail end of this thing, and you get to watch an acrylic project being made. And it's so easy. You've got to get into these lighted acrylic signs. So at this point, if you feel like I've been helping you out and you haven't done it already, give me a thumbs up and a comment down below of what you picked up from this video. And of course, there's a lot of things down in the description box, links and that PDF and beginner's video for that house number sign. If you're brand new to this stuff, you've got to watch that video because literally I take you step by step through the whole process. All right, so I'm going to get back into the Gsender software and I'm going to hit that start button and we're going to watch this thing get carved out, and then I'm going to show you what it looks like lit up, which is amazing. Let's go.
And now we get to start doing one of my favorite things to do on a CNC router, which is engrave on acrylic and plastic. This is the Widget Works diamond engraving bit, the one that I recommend most. It's industrial strength. Most of the ones you find on Amazon, they don't hold up to the harder materials. If you want to cut steel or etch on steel or granite, this is the bit. This bit is used by General Motors, NASA, Campbell Soup. You know, these are high industrial stuff. But look how fast this thing goes. This is running at 40 inches per minute. So you can get a lot of detail really, really fast in this type of project. Links for everything that I have talked about, including the bits and feeds and speeds, the videos, everything is down in the description below. And we're done. You see the clamps, by the way. I make these and I make them available to you as well if you want to make your own clamps, because we have CNC routers to do that. Don't buy clamps. So this is the LED base. I get it off of Amazon. There's a link down below, of course. Very inexpensive. I think it's $12 for 6 of these things. And you can either put batteries in it or USB. And what's cool about this, it can cycle through the various color schemes. You see it went from blue to red, and then you can choose the color that you want. And there's some other, it will flash through colors and what have you. So we're going to put this very special project on this, and for the first time you get to see this with me. And it's a moment I get to share with you of a time that was quite difficult and still hard for my daughter at this time of year. When you're pulling the protective film off the acrylic, just be careful because it's difficult to get off. And you can see the fine details of this, but wait till you see it lit up. So let's show you what this looks like. I love you, Mommy. Remembering Maddox who died in my daughter's arms, her son. And 4 years later, she still grieves. Made on our long mill. Look how crisp and fine these lines are. I love you, Mommy, and I will always be with you. She keeps this in our bedroom now. And I'm going to leave you to this, to watch this sign that means so much. My last message to you is go enjoy your life, because you never know, ever, when your day is the last. In memory of Maddox, my third grandson.